Welcome back to MathDogs. If you're new to the channel, please comment, like, and subscribe. If you have any questions, please comment down below. Problem number 1 is the formula for the perimeter of a rectangle. It says P equals 2 times length plus width. The problem says the fence of the outside play area at the local dog rescue is in need of replacement. The play area is a rectangle that is 36 feet in length and 28 feet wide. How much fencing will be needed to replace it? So in these problems, we didn't put in any diagrams, although the ACT WorkKeys test often does, but we want to get in the habit of drawing a diagram when we read a shape in the problem. In this case, it's a rectangle. So if I read rectangle, I'm going to draw a rectangle to help me visualize, and I know that it's 36 feet in length, so I'll label it 36, and 28 feet wide. Now I'm going to use my formula for perimeter. Perimeter is equal to twice times the length plus the width, since I have two lengths of 36 and two widths of 28. Now, as with most formulas, I'll just fill in for the variables. So I know I want to find the perimeter, since that's how much fencing will be needed. 2 is 2, the length is 36, plus the width is 28. And as with most formulas, it's just a little solving equations or order of operations. So perimeter will be 2 times, I'll work in parentheses first, 36 plus 28 is 64. And finally, 2 times 64 is 128. So we will need 128 feet of fencing in order to replace it. Problem number 2 is the area of a rectangle. The formula says area is equal to length times width. It says the local dog rescue is painting a mural on an outside wall. The wall is 18 feet long and 12 feet high. What is the area set aside for the mural? Now in this problem they don't mention a shape, but it kind of gives me a hint by saying it's 18 feet long and 12 feet high. So I'm going to draw that in order to visualize. The wall is 18 feet long and it's 12 feet high, and when I want to find the area, I want to find the inside space. So my formula says area is equal to length times width. There is an x in the problem. You could also use a dot to indicate multiplication. I'm looking for the area according to the problem. I'm going to fill in 18 for the length times 12 for the width. And then I simply just have to multiply. 18 times 12 is 216, and so I know the area set aside for the mural will be 216 square feet. Number 3 is the volume of a rectangular solid, or basically a box. The formula says volume equals length times width times height. This problem says the shipping boxes at Good Dog Treats Company have a volume of 231 cubic inches. If the height of the box is 3 inches and the width is 7 inches, what is the length of the box? So we know we're dealing with a box and it's a three-dimensional object. A quick way to draw a box is to just draw a rectangle and then go to the center and draw another rectangle and then connect all the pieces together, and you can visualize the three-dimensional box. We know that the height of the box is 3, so we're going to label that. You can label it on any height. And the width of the box is 7. So the width of the box is 7, and we're looking for the length. Now I'm going to go back to my formula. Volume equals length times width times height. In this problem, we're actually given the volume as 231. So I will fill that in for the volume. I'm looking for the length, so I'll leave L, times the width, which is 7, times the height, which is 3. 231 is already simplified. 7 times 3 is 21 times the length. And so to solve for the length, I'll just divide each side by 21. 21 divided by 21 is 1, or as some people say, it cancels out, leaving me with the length. And 231 divided by 21, if you punch that in a calculator, is 11 inches. So the length of the box would be 11 inches. Number 4 is the volume of a cube. It says volume equals the edge raised to the third power. The problem says a metal storage box for tools at the manufacturing plant where you work is a cube measuring 1.5 feet on each edge. What is the volume of the storage box? So it says cube. Again, to draw a cube, this time I'll just draw a square, go to the center, draw another square, and then link all of the little sides together. So there I have my metal box. I know it's 1.5 feet on each edge, so that means all of the edges are the same at 1.5 feet. Now I'm going to use my formula. Volume equals the edge cubed. I'm looking for the volume. I know my edge is 1.5, and I'm going to raise that to the third power. So that means the volume will be equal to 1.5 times 1.5 times 1.5. Or you can just punch in 1.5 to the third power on your calculator. If I multiply those together, or I raise it to the third power, I find out that the volume is 3.375 cubic feet. Number 5 is the sum of the angles in a triangle, and the fact that they equal 180 degrees when added together. The problem says you are creating a plot for an outdoor area. 3 benches need to be placed in a specific arrangement to form a triangle. The angle from the first bench is 100 degrees and from the second bench is 45 degrees. What is the angle formed from the location of the third bench? So I know the arrangement is in the form of a triangle, so let's draw that. It doesn't matter which triangle you draw, it doesn't have to be to scale, you're just getting a visual. The first bench has a 100 degree angle, the second bench has a 45 degree angle, and we're looking for the measure formed by the third bench angle. So I know the 3 of them have to add up to 180 degrees. So I'm going to find out how many degrees I already have by adding 100 plus 45. And that's simply 145 degrees. To find out how much I need to make 180, I'm going to subtract those. 180 degrees total in the triangle minus the 145 degrees I already have. If I punch that into a calculator, I find the answer is 35. And so the angle formed by the location of the third bench would be 35 degrees. Number 6 is the area of a triangle. It says area equals 1/2 times the base times the height. The problem says the new outdoor triangular banner for your pet store needs to have an area of 24 square feet to fit along the outside wall. If the height of the banner must be 6 feet, what does the measure of the base need to be? So again, I see it's a triangular banner, and I want to get in the habit of drawing a diagram to help me visualize. So again, I'll just draw a triangle. It doesn't have to be any specific triangle. It doesn't have to be perfect. I know the area, which is the space on the inside, is equal to 24 square feet. And I also know the height of the banner is 6 feet. So the height here is 6 feet. I want to know the measure of the base. So I want to know how long is this distance across what looks like the bottom of the triangle. Now I'm going to use my formula. Area equals 1/2 times the base times the height. In this problem, I'm given the area as 24 square feet. So I'm going to fill that in as 24. 1/2 is 1/2. I'm looking for the base, so I'm going to leave that as B, and I know the height is 6. Now I'm just going to solve the equation. 24 is already simplified. I know that 1/2 times 6, or half of 6, is 3, so I would have 3 times the base. And then to simply solve for the base, I'll divide both sides by 3. 3 divided by 3 is 1b, or as some people say, it cancels out. And 24 divided by 3 is 8. So the length of the base must be 8 feet. Number 7 is circles and the number of degrees, specifically the fact that there are 360 degrees in a circle. This problem says you are creating a mosaic tile circular tabletop for an interior designer. One tile piece fits into the circle with an angle of 70 degrees. How many degrees are left for the other tile pieces in the circle? So again, I have a circular tabletop, so I'm going to draw a circle. Doesn't have to be perfect, that one definitely is not. And I know that one of the tile pieces fits in at 70 degrees. Again, you don't have to have exactly 70 degrees. I'll just kind of find the center and say that's the tile piece that I have at 70 degrees. I want to know how many degrees are left within the circle for the other pieces. That's just going to be a subtraction problem. There's 360 degrees total, and I already have one piece that uses up 70 of those degrees. So if I punch into a calculator 360 minus 70, I find out that answer is 290. And so there's 290 degrees left for the other tile pieces in the circle. Number 8 is the circumference of a circle, which is the distance around the outside edge. The formula says circumference is equal to pi times the diameter. This problem says you are creating a frame for a local artist who has painted on a circular canvas having a diameter of 32 inches. You need to finish the frame by putting an edging around the outside. About how much edging will you need for the frame? So again, in the problem I see it's a circular canvas, so I'm going to draw a circle. Doesn't have to be perfect, it's just to visualize. Then I'm going to label my diameter as 32. So I'll find about the center and draw a line from edge to edge through the center. That's my diameter of 32. Now I'm going to use the formula. Circumference equals pi times the diameter. I'm looking for the amount of edging around the outside, so that means I'm looking for the circumference. I'm going to approximate pi as 3.14, and I'm going to multiply that by the diameter of 32. Circumference is already solved for. I just need to multiply 3.14 times 32 in a calculator, and I will have 100.48, which is rounded off to 2 decimal places. And so the circumference would be 100.48 inches, and that's how much edging I would need. Number 9 is the area of a circle. The formula says area is equal to pi times the radius squared. This problem, you have been contracted to build a circular outdoor patio to be filled with stones. The patio will have a diameter of 18 feet. What is the area of the patio? So again, it's going to be a circle, so I'll draw a circle. I'm looking for the area of the patio, which is the amount of space on the inside, and I know the patio has a diameter, again I'll find the center and go from edge to edge, of 18. However, in my formula I want the radius, so I only want the distance from the center to one of the edges. That means I'm going to have to take 18 and divide it by 2, and that will give me 9 for the radius. Now I can use my formula. Area is equal to pi times the radius squared. I'm looking for the area. I'll approximate pi as 3.14, and my radius I just found as 9, which is half of the diameter, and that's going to be squared. Area is already solved for. It's just a little order of operations. First, I'm going to raise 9 to the second power, so 9 times 9 is 81, and then I'm going to multiply 3.14 times 81. If I punch that into a calculator, I'll find out that the area of the patio will be 254.34 square feet. Number 10 is the volume of a cylinder. And the formula says volume is equal to pi times the radius squared times the height. In this problem, an ingredient container at the dog food factory where you work is a cylinder that measures 5 feet high and has a radius of 1.5 feet across. What is the volume of ingredients that the container can hold? So again, I see the word cylinder. To draw a quick cylinder, you kind of just draw a flat circle, and then you draw down each side, and you draw across the bottom. That's a good enough visualization. It's just to give you an idea of what's happening. I know that the cylinder is 5 feet high, so I'll label the height of 5, and the radius across the circle, I'll find the center about, label it to the edge, that's 1.5. Now I'm going to use my formula. Volume is equal to pi times the radius squared times the height. This problem says what is the volume? So I'm looking for the volume. I'm just going to substitute for everything else. For pi, I'll approximate it as 3.14. I know that the radius is 1.5, and that's going to have to be squared, and I know that the height is 5. So the volume's already solved for. It's just a little order of operations. First, I'm going to raise 1.5 to the second power. So 3.14, 1.5 times 1.5 is 2.25, and that's still going to be multiplied by 5. Now I just have to multiply those three numbers together, and when I punch 3.14 times 2.25 times 5 in a calculator, I get 35.325 cubic feet for the volume. 11 is the volume of a cone. And the formula says volume equals pi times the radius squared times the height, all divided by 3. The The problem says at the garden store where you work, there is a hanging planter in the shape of a cone. If the height of the planter is 8 inches and the diameter across the top is 6 inches, about what volume of soil will the planter hold? So I see in the problem there's a cone, and since it's a hanging planter, I'm going to draw it in an upside down way. So there's my circle, and then I'm just going to kind of draw a triangle looking thing. There's my cone. I know that the height of the planter is 8, so the distance from the center down to the tip of the triangle piece is 8, and I know that the diameter across the circle would be 6. But I also know in my formula I want the radius. So I'm going to take the diameter of 6 and divide it by 2 to get 3, which would be the radius, since a radius is half of the diameter. Now I can use my formula. Volume equals pi times the radius squared times the height, all over 3. I'm looking for the volume of soil, so that's already solved for. Pi will approximate as 3.14. The radius we just found was 3 squared, and the height we found as 8. And all of that multiplication is going to be divided by 3. So now on the top it's just an order of operations. First I'm going to square 3, so 3.14. 3 squared is 9, all multiplied by 8, and then divided by 3. So I do have a fraction. I'm just going to multiply across the top. When I multiply 3.14 by 9 by 8, I get 226.08, and then I'm going to divide that by 3. And when I punch that into a calculator, I find out that the volume of the planter will be 75.36 cubic inches. Number 12 is the volume of a sphere, which is just a ball. The formula says volume equals 4/3 times pi times the radius cubed. In this problem, you are a quality control inspector at the Fetch and Play Corporation. One of the balls produced has a diameter of 4 inches. When you test for quality, what volume of air should the reading show? So, it's kind of tough to draw a ball sometimes, but I usually just draw a circle, and then I put a little thing here to show it's a three-dimensional object. But I do know that the ball has a diameter of 4. Remember, it's just a visual to help get your brain thinking. It does not have to be perfect. Obviously, mine is not. But now I can use my formula. Volume equals 4/3 times the pi times the radius cubed. I'm looking for the volume of air when I test for quality. That's already solved for. Then I have 4/3 times 3.14, and the radius is going to be half of the diameter again, so 4 divided by 2 is 2, and that 2 is going to be cubed. So now I just have some order of operations. Volume will equal, I'm going to take 2 and multiply it by itself 3 times. So I would have 4/3 times 3.14, and 2 times 2 times 2 is 8. Now I'm going to multiply together 3.14 times 8, and then I'll deal with the fraction at the end. So 3.14 times 8 is 25.12, and I'm going to put that over 1, so now I have two fractions. Multiply across the top, multiply across the bottom, and then divide at the end. So 4 times 25.12 will be 100.48, and 3 times 1 will be 3. When I do my final division in my calculator, I find out that the volume for quality control should be 33.49 cubic inches. Number 13 is electricity, and the fact that 1 kilowatt hour is equal to 1,000 watt hours. This problem says a 40-watt porch light stays on overnight for 7 hours. How many kilowatt hours will this be? So first I'm going to have to find the total. 40 watts times the 7 hours, so 40 watts times the 7 hours will give me 280 watt hours. So I have 280 watt hours, but I want to know how many kilowatt hours that is. So if I put this over 1 to make it a fraction, I can use the factor label method. 280 watt hours, I want to know what 1 kilowatt hour divided by 1,000 watt hours are. So I have 1 kilowatt hour over 1,000 watt hours, which is actually equal to 1, but I will get my watt hours and my watt hours to divide out. So 280 times 1 is 280. 1 times 1,000 is 1,000. And if I divide 280 by 1,000, I find that that's 0.28 kilowatt hours. Number 14 is also electricity. And in this problem, it tells us that amps is equal to watts divided by volts. In this problem, it says how many amps does a light with a 60 watt bulb draw if it is plugged into a 120 volt outlet. And so I have my problem, amps equals watts divided by volts. So I'm looking for amps, which that's already solved for. I'm going to substitute 60 for the watts, and that's going to be divided by 120, which I'll substitute for the volts. And so if I punch that into a calculator, 60 divided by 120 will be 0.5 amps. Number 15 is temperature and converting from Fahrenheit to Celsius. The formula says Celsius is equal to 5/9 times the Fahrenheit temperature minus 32. In this problem, it says to complete a test in the lab where you work, the protocol states to heat a solution to 122 degrees Fahrenheit before adding the sample. What is the temperature in degrees Celsius? So I'm going to use my formula. C equals 5/9 times the Fahrenheit temperature minus 32. I'm looking for the Celsius temperature, and that is already solved for. 5/9 is 5/9. And I'm going to substitute 122 degrees for the Fahrenheit temperature, and then I will subtract 32. So, in this problem, I'm going to use the order of operations. First, I'm going to work inside parentheses. So the Celsius temperature will be 5/9. 122 minus 32 will be 90, and I'll put that over 1, so I have two fractions. Now I'm just going to multiply across the top and multiply across the bottom. 5 times 90 is 450, and 9 times 1 is 9. And now I can do my final division, 450 divided by 9, and I'll find out that the temperature in Celsius would be 50 degrees. Number 16 is also temperature, but this time we're converting from Celsius to Fahrenheit. This problem says an instruction manual for a fabrication company states that the raw materials must be kept above 15 degrees Celsius. What is this temperature in degrees Fahrenheit? So I'm going to use my formula. Fahrenheit is equal to 9/5 C plus 32. And I'm given 15 degrees Celsius, and I want to find out the Fahrenheit. Fahrenheit is already solved for. 9/5 times, I'll substitute the temperature in degrees Celsius of 15, and I'll put it over 1 because I'm going to have to multiply it by a fraction. And then I'm going to add 32. So, first I'm going to multiply 9 times 15 across the top, which is 135. And then I'm going to multiply 5 times 1 across the bottom, which is 5. And then I'll add that to 32. So if I punch in a calculator, 135 divided by 5 is 27, and 27 plus the 32 will be 59 degrees Fahrenheit. So that's it, an example of all of the formulas on the ACT WorkKeys Formula Sheet. Keep working hard, keep practicing, you're definitely going to be successful. Remember, as we say at MathDogs, you got this.